when it gets factored and I want to find a number answer, what do? So we're actually going to start a step ahead. So when we're trying to solve an equation, and it's already factored, and we'll get to somewhere we got to factor them out ourselves, we want to set anything, okay, and that includes parentheses, with an x equal to 0. So when I say anything, I literally mean anything. So for instance, this x that's sitting here by itself, I'm setting that equal to 0. That x plus 4, it's in the parentheses. There's an x there. I'm going to set that equal to 0. Now the first one's already done. That's kind of cool. Nothing else I can do to it. But the other one's just a basic equation. How do I get that plus 4 out of there? Minus 4. And what basically this does is, if I plug either of those numbers in, it'll make one of my factors equal 0. And if one of my factors equals 0, anything times 0 is 0. So that's what makes this work out. Okay? So, and that's going to be true on any of these. So again, anything I see, a little bit, yeah, there's some pieces to this that should be similar or familiar to what we've seen before. So I'll set that equal to 0. I'm also going to set what's in the parentheses equal to 0. And again, solve it just like you would a one-step equation. And again, on the other one, since I'm minusing 5, I just do the opposite and I add 5. And I get my second answer and I'm good to go. And I just kind of keep working my way through on these, taking on that same idea. If it has a variable with it, I set it equal to 0. A variable anywhere within it, I set it equal to 0. Now, if there's nothing else to do to it, I can just circle it. It's one of my answers. Now, sometimes it may not just be one step, though. So like here, I got to get whatever's furthest away from my A out of there first. Yep, and I'm perfectly good with you leaving answers as fractions. So like 5 over 2 doesn't go in even. Just leave it as 5 over 2. If you went to 2.5, went to the calculator, that's okay. But that's kind of the concept that we're rolling with here. One more up in this part, and then I'm going to change up just a little bit on you. So number 5. Same idea. 6n equals 0. 4 minus 5n equals 0. And I'm just going to go ahead and solve these. So how do I get n by itself in my first equation? Okay, we're just going to divide by 6. Exactly. So here, if I minus the 4, because it's a positive 4, got to do the opposite. For my second equation, though, what would my last step be? Since I'm multiplying n by negative 5, what would the opposite be? Okay, I'm going to divide by negative 5. So fractional answers are okay too. Well, what if I don't have a number out front? What if I just have 2 sets of parentheses? Do the same thing. Each set of parentheses, as long as there's a variable, So I may have two equations that I have some work to do on. So what's my first equation? What's my one step? Minus the 3. And the second one? Plus the 8. And I go about my business. Oh, let's do one more here. Let's see. Let's try out 9. All right. There's a Q in each parenthesis. All right, first equation, what do I need to do first? Okay, right, because I'm trying to get the Q term alone. And then what would be my last step to get Q by itself? Divide by 3. What about my second equation? Negative 1/3. Okay, minus the 9. Exactly. Once I get my Q term alone, okay, so if they're already factored, each part that has a variable we need to set equal to 0. What if it's not factored right away? What if it's something sort of like what we've got down here at the bottom? Yeah, we got to take out what they have in common, sort of like what we were doing yesterday first. Then we can factor it. So for instance, what do these two terms have in common? Yeah, I was going to say, they both have a t. I can't really do anything with the number, but I can take a t out because, again, a single t is the single smallest exponent that I've got. So now we're going backwards here. T times what gets me to t to the second? T, because t and t gives me 2 of them, or t squared. Yep, and I've already got the t in the second one, but I need the minus 8, or the negative 8. Because if I distribute, t times t is t squared, t times negative 8 is negative 8t. And now it's just like what we were doing up above. I take each item that has a t and set it equal to 0. Yep, first one I don't have to do anything. And I'm ready to roll. So the concept's not really different, it's just we can start to put things together. Now let's see here. 14. 2 and 11 is there anything that divides into 2 and 11? Okay, just 1 here. So I can put the 1 out front, or if I didn't put a number I could. And then right, they both have a y, smaller exponent on the second one. So I can put y, or I can put a y to the first. That'd be okay too. And just a reminder from yesterday, again, our process to fill up the parentheses is, now I'm going to take that 1y, and I'm going to figure out what do I multiply that by to get each of the terms that are here. So 1 times 2 is 2. And if I have 1y and I want to get to 2, I need 1 more. 1 times 11 is 11. And I already have the y. And again, at this point, I just set each part equal to 0. First part's good already. And then again. And then just divide by the 2. And again, no big deal. If it's a fraction, we're good with it. So it kind of combines the 2 days worth of material to get things situated the way we need them to be. Any issues so far? Because I think on the back we're just going to be doing a little bit more of the same type of thing here. All right, let me flip over here. All right, let's find one. Yeah, this is kind of going into review from yesterday. All right, let's say no equals 0, so I don't have to finish these. I don't have to solve. Let's say, well, let's say we're looking at 16, because a little practice from yesterday doesn't hurt. Does anything divide into 3 and 9? Okay, 3 does. And again, I can use the chart or I can just divide numbers in with my calculator. Okay, so I can get a 3 out of there. Anything with my variables? They both have x's. I take the smaller, so I just take the x. And again, my goal now is to kind of undo the distributive property. 3 times 3 gets me to 9. And I've got 1x and I need to get to 2 of them, so I need another one of those. Exactly. Here, to get from 3 to -3, I'd multiply by -1. And I've already got my single x. Since there's no equals 0, I'm done. So again, keep life simple. Or let's say we got 18. Ooh. 14, 42, and 49. What might work with all 3 of those? Let's see here. 14, 42, 49. 14, 42, 49. Love the chart. Okay, looks like it's 7. So let's go with 7. What's my smallest exponent on my t's? 3. So I got t to the 3rd. And now I'm ready to build the rest. So again, piece by piece. 7 times what is 14? And if you're not sure, you can always use the calculator and you could do like 14 divided by 7. Because you can kind of do this backwards too if you need a little bit of assistance. So I can always take the bigger divided by the smaller. Okay, so that'd be 2. So I'd have 2. Yep, I already got the t to the 3rd. Don't need any more. That'll be 6t. Yep. To the 2nd. Since 42 divided by 7 is 6. So I'd have 6 t to the 2nd. Because 3 plus 2 is 5. And then 7 times 7 is 49. I've got 3 t's. I want to get to 4. I need 1 more. Just do it in pieces. Pieces, pieces, pieces. And then you can always make sure you got the answer right if you go back and distribute. 7 times 2 is 14, t to the 3rd. 7 times -6 is -42. 3 and 2 is 5 t's, good. 7 times -7 is -49. 3 t's and 1 more give me 4. Awesome. And then finally, down at the bottom here, again, FOIL or the box. I know we did this a little bit, a couple days ago. But again, and I'll just do it both ways just to kind of help some of you out. Whenever you see these, Doesn't matter which side, which set of parentheses goes on. But when I'm doing these, okay, if I'm doing the box, I'm going to multiply to fill the box. Then I'm going to combine like terms.
And it's pretty much the same thing as we did that one time.
Uh-huh.
Why are we doing it again?
Because we've got to spiral through, because I've also got a large group of people that can't even do the basics with this right now, so I want to make sure it can work out all right.
Gotcha. I understand.
All right. So, as we fill this in, again, add my exponents. So I've got x squared, this is 1 plus 1. Negative 2 times x is negative 2x. 7 times 3 is 21. And 7 times negative 2 is negative 14. And again, the nice part of this is the terms that are alike always end up in the diagonal across from each other. So 3x squared, 21 minus 2 is 19. Minus 14. And again, you don't have to do the box. I like it because it's visually organizes everything for me. But if you're not a big fan of the box, let's say, like, yeah, I don't really like that. Okay, let's do 24 using FOIL. Now, squared doesn't just mean I get to distribute it. I've got 2 of these. So if I was going to go the FOIL route, I would go first. 2 times 2 gives me 4x squared. Add my exponents. Outside, 2 times 3 is 6x. 3 times 2, again, is 6, and I have an x there. And then my last, 3 times 3 is 9. And again, it kind of makes the smiley face guy there, makes sure I got them all. And then I just work left to right. And when I go to combine like terms, remember, I'm not messing with the exponents anymore. And whether I do it by FOIL or by the box, I'll get the same answer for every one of these. That will not change no matter what. So as you can see, we're going to blend in some of the other stuff as we're doing these, but it's not going to be anything that's too terribly awful. So your job, and again, with this being a note sheet, keep it handy, because it always can come in handy if you want to use it on a quiz or a test anytime, is basically on the front of this worksheet, they're already factored for you, so you're just going to set each of the terms equal to 0 and find the answers. However, when you get down to that second part, when you get down to number 15 through the end, it's going to be basically more of what we were doing up at the top of the sheet. We're going to find what all 3 things have in common, and we're going to factor those. Okay? And I've got 6 of them on here to get you a little bit of practice, again, in messing with these. Now, the one other thing to mention, because I am going to do one of these with you, number 18 actually, is that sometimes you'll have terms that aren't the same in all of them. So like here, for instance, maybe you notice right away, you're like, okay, 10 divides into each of those. I'm like, okay. But then you've got to be careful with the variables, because some of you may put a, b. You're like, well, that's the smallest exponent, but my first term doesn't have an a or a b. So I can't pull out a term unless it has it in every one of the terms. So 10 is actually my greatest common factor on this one. So 10 times 10 is 100. Or if I wasn't sure, just that reminder out there again, you always can take the number in the problem and divide it by your greatest common factor. That'll tell you the number to put in there. 10 times 8 is 80. but I need both of the variables because I didn't pull any of those out as part of my factor. And the same thing for my last one. 10 times 5 is 50, but I don't have any A's or B's out here, so I have to include all of that. And that's how these work. Tomorrow we're just going to spend one more day kind of doing a little of all of these. And then Thursday we're going to do a mini little quiz just to kind of get back into the quiz run and kind of see how things are going with these before we get into the bigger stuff with it. And that's about it.